Hey, hey, remember those annoying little functions from high school called cosine and sine? Everyone said you're not going to use them for anything in real life, but look what you can do with them. Look here. This cube is bouncy. I wrote this script called bouncy.cs and used time.time as the input for a sin function to scale it, which makes it look like it's bouncing in space. And then I also set it up so the player has a ray to activate things when looking at them, and it toggles a variable should bounce. So this is great for debugging if, for example, you should be able to interact with something or not, if you want to pick something up, or if you're looking at a certain thing. I can just chuck this bouncy.cs script on it and see if it's working. And yeah, I initially wanted to write an outline shader for this, but I thought this would be more fun during prototyping. And yeah, like I mentioned, who doesn't want a bouncy script that you can just chuck on anything you are currently debugging, anyways? Apart from that, this is my new project that I'm working on, a game called Reldfire that is all about building, crafting, exploring, and stopping the Reldfire. I started this project by making a little book model, since that is what you use to unlock a lot of recipes in the game. Then you obviously need to go out and explore to find these books and blueprints while making yourself stronger for exploration in your base. I wrestled a bit with making the displace modifier work for the book, but I eventually figured out how to do it. I just had to set it to UV coordinate space, and then it was just a matter of fitting it to the model's UV map. And then I went into Unity and set up input. I actually first used the player input component, but then I read the documentation again and realized that Unity actually has an even easier method for taking input, and that's just directly accessing an input action variable. So I rewrote my player movement script to use that instead. After input was done, I set up movement. I learned that Unity actually does quaternion math under the hood, leading to terrifying behavior if you try to modify using Euler. For example, looking forward, then down 90 degrees, and then continuing to look in that same trajectory, one would expect that you eventually start to look at 100 degrees, then 110, then 120. But no, it starts to count down again instead. So yeah, that's just what happens when there's a hidden conversion to quaternions that you don't really see immediately in the editor. But then I just started using quaternions instead, and now it works perfectly fine. When that was done, I mapped mouse input to the forward looking vector. So pressing the D key always moves you to the right in relation to the direction you're looking in. And I decided to make it so that sideways movement with the mouse moves the player capsule, while looking up and down moves the camera. Um, I found this to be a nicer approach because it's closer to what you would actually want with an actual humanoid model, where you move the entire body if you move around the y axis, and if you move along the local x axis, you want to move the head of the model. So I just wanted to mimic that a little bit. And movement itself does not use physics, it does not use rigid body. You just directly manipulate the player's local position vector using the translation method. But jumping does use physics, and that's because it's easier. I have written my own gravity and jumping scripts before, and they take quite a bit of time to write. So yeah, and this also allows you to stop and move around in midair, which gives you more control over the character, but it also behaves less realistic, trading realism for air control. and I also learned that Unity has a pretty nice collision detection built into the rigid body class, and I use that to determine if the player is standing on something relatively flat or not with a dot product between the capsule's up vector and the surface normal in the collision information. And that determines if they enter a so-called grounded state, which puts it into basically ground locomotion mode. And that's mostly what I've been able to do. I've worked on this for a total of 5 hours now, and it's really fun. It's very fun. And yeah, thank you for watching. Please subscribe and like the video. It will help me make this a regular thing. Have a great day and dev on.